indicators individually or performing a multi-selection of indicators and tag them all at once. Since the tagging is a free form, I recommend the practice is to create a standard naming conventions for threat indicator tags, and we can apply also multiple tags to each indicator. The indicators will reside in a threat intelligence indicator table. That is actually a name for that. So to view our threat indicators with KQL, we can select the logs from the general section of the Sentinel menu, and then we can run the query by calling the threat intelligence indicator table name with no spaces. That is the actual built-in the name, and we can just write the threat intelligence indicator and select it, or highlight it, and run it. And we should display the threat indicators on a result from the output of the KQL engine or editor. All right, that was the final part of the final lesson, guys. So let's go for the final guided demonstration. From the previous guided demonstration, I just show you how we can create the workspace and its requirements also represented, for example, by the login in workspace, which is the main requirement. That we also understand that there is different scenarios depending on if we have some legal obligations like storing and retaining the data into data center region geographic locations to make sure that we're in compliance basically on it, to create one or multiple with single or multi-tenant access on. We also understand that in order to start displaying some information by going hunting, by displaying some incident option, and for the manual or automated response on incidents finding or suspicious events that we can found from the options, we need to have data sources connected already. Now, with this guided demonstration, let's go to a process of once that we have the collected data, how can we start querying the data, how we can go in hunting, and how we can, well, I already show you how to configure workbooks, for example, for connected data on it. In this case, let's now follow a process that after we just collect some data for accessing the querying engine, for running custom queries, or for using existing built-in template queries that we can use as our reference to create some other complex queries or tenant under the context of our own log collected data. And okay, if we're creating a new workspace, like in my case, and I did not have any log collected source yet, or if I have one, I just going to display like a few events, for example, on it, because the log collection is pretty new and no events reported. If I would like to practice with the KQL, if I'm not familiar with the custom query language and not familiar with the Microsoft Sentinel and the security operations and going hunting and the queries, how they work, the operators, the table names, and so on, I would recommend you guys for using, for example, there is a publicly available querying or login in workspace available for testing that we will have by default read-only permissions for that workspace. You can perform a quick search of Log Analytics Workspace Demo using any search engine like Bing or Google, for example, and you can get to a Log Analytics tutorial from the Azure Monitor, official from the Microsoft.com, the docs.microsoft.com, sorry. You can click on it and you will read an entire article on. You can look for this Log Analytics tutorial also. It's a tool, the Log Analytics in Azure, to edit and run log queries from data collected by Azure Monitor logs and interactively analyze their results. So you can use these queries to retrieve records that match particular criteria. And this tutorial walks you through the Log Analytics interface, get you started with some basic queries, show you how you can work with the results, and you will learn the following. Understand the log data schema, write and run simple queries, modify the time range, filter, sorting, and grouping query results, view, modify, and share visuals, and load, export, and copy queries and results. If we can see that in order to starting testing with the workbooks, with the building our queries to find out if we're writing with the right syntax and we should expect to see some output from there, we will need to have a more robust Sentinel service and a workspace with multiple sources collecting data from existing resources that are also creating events for testing with those querying logs basically on it. So in that case, only users with active subscriptions to create those resources and just for testing, for example, will have the possibility to do that and for starting collecting the logs. And we're consuming some services from that with the amount of storage space that we're consuming for that. So basically, we need to have an active subscription and pay for that. If we just need for testing, if we just need for practicing, for having some kind of safe environment to test, to study, and to practice, you can consider this Log Analytics Demo environment. You can click on this link and you will be redirected. You can see maybe up to a prompt for asking you for authentication. And you can authenticate by using a work or personal account. And you will see the Azure portal opening the log querying editor here. And you will have read-only permissions to this one. So important to say, this is not my workspace. This is not my workspace from my Sentinel. This is a publicly available workspace and this querying editor on it that I can start using by testing. There is a lot of resources connected here. I can see it by the multiple categories on it. If I'm checking in into my Sentinel service, for example, and if I would like to access into the log editor or to the querying editor here, I can click on the logs and I can display the same user interface, and I can see my table list with the schema of the day 3 LAW for Sentinel. And there is no tables to display. Well, why is that? Because I don't have any data source connected. And if I do create one, then I will see just a couple of tables only, maybe. There is just little information on it to test, basically. From the public available one with the second tab, we can find out that there is, into the tables view list, multiple categories with n number of tables on. So how this KQL editor works on? All these options from these categories are displaying existing built-in tables from the schema. I can hover over a table name and I can read a quick description on. This health state change event is displaying some workload monitor health, and these data represent state transitions of a health monitor from the Azure monitor for VMs. I can see a VM computer table name where inventory data for servers collected by a service map, a VM insight solution using dependency agent analytics information will be displayed. VM connections for traffic for inbound and outbound connections to and from monitor computers, or VM process. Process data for servers collected by the service map and VM insights and so on. Okay. Now, the querying editor is at the right and into the top. Here I can start writing a name of a table. This editor is context sensitive. So as I'm writing a table name, it can try that I'm trying to look for. For example, I can take the reference of the VM computer. By just typing VMC, it can start filtering, and it's context sensitive that the table names that start, or the operations that start with the VMC are this one: VM computer, VM connection, and VM process. Okay, so I can select it or use the tab for the autocomplete process. Okay, would you like to run the query just by displaying all the content from that table, or you would like to start adding some operators for starting filtering the data using the where, the count, the extend, join, limit, lookup, order, project, and so on? Multiple operators on it. Parse, union, evaluate, sample, serialize, and so on. Sort, summarize, render for displaying a different output format. Now let's start with a simple query of just calling the table name to find out if there is information into that table. I can see a completed operation and showing results from the last 24 hours on it. 481 records display in less than 2 seconds on. I can scroll down and I can see, okay, if I just hover over the VM computer description also, I can see, oh, this is an inventory data for servers collected by Service Map and VM Insight solution using dependency agent and the log analytics agent all. Okay, so here, this is an inventory that I'm displaying. A time generated, a computer name, an agent ID, machine ID, display name for that computer from the Azure resource context, full display name for that, a host name, boot time, time zone, virtualization state, IP address reported with an IPv4 or IPv6, IPv4 subnet mask, default gateways that they're using, IPv6 if it is supported, MAC addresses reported, DNS names, dependency agent version installed, and the operating system version on it, and the system full name on it. But I can see here the additions, 2016 with Windows Server and a mix of Linux operating system, for example, on with Ubuntu 16.04 or something like that. And now, okay, the 480 records are divided into this default display view into this table format across 10 pages with 50 items or 50 rows per page. If we have a total of 481, the 10 pages with the 50 records on it, it is for allocating records of up to 500. So that's why this is my default display view, for example, here. But I can use the other operators to starting filtering the data. If I would like to filter by the operating system full name and define, let me just display me only the ones that are using Linux. And then from the 100% maybe on a small percentage, 30%, 40, 20, 10, for example, will be computers that are using Linux on. So I can start by filtering by and only display me the information from the computers that are reporting that operating system reference on. Okay, so we can start from nothing, no guidance, just by looking at the schema and calling table names on, and working with the possible operators and working with the context-sensitive query and editor. That is one option. Now, if I do have, which is not the case for this, write permissions on this one, I could, by writing and looking at the result from my queries, I can save this query to my private repository. I can share with others. I can create an alert rule based on this output. I can export this information to a CSV, to all columns or display column, open it in Excel or export to Power BI. Another option for practicing and testing or be familiar with the querying syntax on it is opening this little queries button on the top menu. By opening hundreds of built-in queries for common operations on it, or for common queries that multiple organizations can start to use. I can see it like with the schema with the tables on it. There is arranged by categories, for example. And by looking at, if I'm looking for a specific category, I'm looking for built-in queries for applications, for the Azure Monitor, for Azure Resources, for databases, for networking, for virtual machines, and so on. We can select, for example, the virtual machine built-in queries on. And I can see the section where the virtual machine category starts. And these are the first queries for the virtual machine category. So I can read a description from the built-in template query. For the listing the collected performance counters and object types from the process, memory, and processor for virtual machines, or chart the VM's available memory over time, or chart the CPU usage trends, or show the latest report of free disk space per instance on a virtual machine, display the VM reported availability during the last day, or show error events from the last hour. For example, we can click here to load the editor to the querying editor user interface, and we can see, okay, a common section for a query and sections that we can also create into our custom ones. The first three lines are representing comments with the double slash. The color of the text is automatically configured as green for the comments. Into the comments, I can see a name of the query and description for the query and details for it. Reported errors is the name, show error event from the last hour is the description, and then a series of steps, for example, or recommendations to create an alert for this query. You can click on the plus for a new alert rule when you are running this query and when you have the permissions to do that. So from here, I can see how this query is created, but it's using an operator of union of two tables, the event and separated by commas, event table and the syslog. The event table will store Windows event records and the syslog is storing Linux records on it. So I'm looking for reported errors within this query independently or the type of operating system that they are using basically. And now, after using the union of the two different table names into one, I will apply the filter. I will have, like if you're familiar with PowerShell, this is going to be a way similar on it, that we can use the pipes for sending the output generated for our first command as an input for the next one for processing and filtering the data. This is something similar. From the line number 4, we're creating a union and combining or merging two tables into one. So we have like an overall result that is the two tables into one output on. But also, I'm just not looking for the entire logs for the event and syslog table on it. I would like to display something really specific. So after merging the content from the two tables, then I can start using the pipe and the filtering of using the operator of where the time generated is greater than an hour ago. Or no longer, sorry, than an hour, basically. And using another filter with a different pipe for specifying the operator of where the event level name is equal to and is displaying an error status from them. There could be multiple status on it, but I'm pretty sure, but I'm sure that the status that I'm looking for this option is the word of error on it. So I can use in between quotes that the event level name is equals to error, then display me that information only. Or when the severity level is equals to and under quotes ERR, that it could be a shortage for the error on it, also display me that record. The event level name is using the event Windows record, and the ERR is for a severity level when we have a computer running Linux. Remember that we are looking for Linux and Windows computers on. So we can run this command and we should display errors results on it. So right now I can see no results found from the specified time range, for example, on it. We can try to select another time range by reconfiguring the time generated, go 1 hour, for example, or selecting into the operators. Sometimes it functions with a D for using 1 day. I can use the tab to complete this option. So instead of no more than an hour ago, no longer than a day, for example, with 1 day. We can click on run and no result for the time generated, for example, or maybe there is no errors reported for the computers that this repository is collecting. Not so sure because I don't have the full control about this repository. But this is a common structure into KQL queries on it, that using tables, using operators, and using pipes and other operators for further filtering the information from data. Let's take a look for another type of query. Again, looking for the virtual machine categories that we should be able to see some information. Let's test with the virtual machine free disk space available, for example. Into the same querying editor, we can separate with a line another query to run. It doesn't matter. It's not going to run the two queries at the same time. We can just use the space for highlighting from the line number 9 or the row number 9 up to the 17 that is considering my own query to highlight it and run it. And it will only run the first query, for example. If I would like to separate the queries, I can open a new tab and then I can copy and paste or opening the queries built-in table list and clicking on there for pasting into the query editor into a new query option on. This is good for the separation of the queries if I would like to save it as mine in my private repository, for example. This is the query for this and this is the query for that, basically. But if I'm just using for testing, you can use into the same tab as many queries that you, as soon as you can identify where one query ends and when the other starts. I can identify that by the comments on. So the second built-in query that I just wanted to test is the virtual machine free disk space. The description says that showing the latest report of the free disk space per instance, and to create an alert for this query, we can click the new alert rule. That same recommendation as the previous one. So right now, this is starting into the row number 12. Calling the performance table, that the official name is the PERF for perf, are shorted for performance. And then we're using the pipes and the operators for starting to filter in the option 4. Because if I'm running the perf query, I will see hundreds or thousands of records about the performance of the many computers that this workspace is collecting already on it. As you can see, we're displaying the maximum limit of a result from the user interface. That is 30,000 results. And there is more than that, for example, but I'm displaying the limit on. And there is a lot of performance information from this table. That is time generated, computer, object name, counter name, instance name, and so on by scrolling horizontally. Okay, just calling the table is not enough, and it's not like a functional information that I can use. But I understand that there is data just by calling the perf data, the perf table, basically. Now, I can see that there is other filter like that where the object name is equal to logical disk. I'm looking for this table only, and I'm looking not just for logical disk options on it, and the object name used in Windows records on. And where the object name is equal to logical disk, the object name is used in Linux record also. Remember that we can also look for the available disk independently if it is using Windows or Linux. Also another operator where the counter name is equal to 3 megabytes on it, and summarized by the argument maximum, time generated, separated by a comma, and a wildcard, everything by an instance name, and the argmax over the time generated will return the latest records on. And finally, I wanted to project, and in other words, only display the time generated column, the instance name, counter value, computer, and the resource ID. After processing and filtering all this data, I would like to see this information only as the result. So I can highlight from here, from the row number 12, and clicking on run, and find out if we can display some result on this one. So in this case, we can project the time generated on it, the instance name, the counter value, the computer, and also there should be a resource ID. So I'm just displaying only the information that I would like to see on. This counter value is representing megabytes, for example here. So I can see an instance name that is representing a volume letter from the disk. C drive usually used automatically into Azure virtual machines for the operating system. A D drive or D letter is representing a temporary drive that is an SSD for the performance of the virtual machine itself. There is an F drive that should be like a data disk, for example, and it's available option. We can see on which computer these volumes are associated, for example. So, and the counter value is displaying into megabytes, for example. 96,000 will be representing like 96 megabytes, or this is equivalent to a virtual disk with 100 gigabytes of storage space. The D drive, this is the temporary one, usually will be a short volume, for example, because it's only a temporary drive for the performance of the VM itself. And the data disk is another regular volume that is, for example, using 130 gigabyte or 140 or 150 or something. So we can display all this information. And I can play with the output by reconfigure this option into charts, and by looking at the infographics here, by looking at the, okay, what are the columns into these columns are representing? The green one, for example, are representing the F drive. The blue or the light blue option is representing maybe a total or something like that. So I can see it on this one. I can zoom in and zoom out and so on, or I can export this information, or I can pin this information to a dashboard. Or if I would like to use this information and the output for this command, or sorry, for this query into my workbook, that I can copy from here and I can return to my workbook or to my Sentinel service and my workbook's context on it, creating a new one. And into my section, by clicking on edit, I can start, okay, I would like to display the available free space, and I wanted to see it on a frequency on. As soon as every day I'm adding new content to my virtual machines or to my data disk, I would like to see in real time the available storage space or the storage space consumed from the volumes on. So I can click here to edit, and okay, adding, for example, a query, and I will see the space for the query, and I have an option here to just come here and paste it. I will understand the type of graphic that I will display here. When I'm done with this editing option, then I can click on done editing, basically. But remember, I was using the KQL that I have only read-only mode. So this is not actually my sources on it. It is some publicly available connected source from this one. And then in this case, I will need to have like my connected source from my repository, from my workspace, and from my Sentinel service, and then using my Sentinel resource for creating my workbook, and then to starting visualizing the data from here. So I will never visualize nothing from a query that I'm just calling from a different data sources on. And I will never see a performance information output if I don't have any computer being collected, for example, from this workspace and from the Sentinel, basically. We can also use the Sentinel for going hunting. For example, let's select the log analytics for Sentinel that I just create for today's session, and we can locate the threat management option, and we can click on the hunting options. Going hunting is going proactively for trying to find something that is not a known threat yet, for example, on it, but we would like to find something and hunt for something suspicious on. Let me just reconfigure the visualization option because, well, there is like a lot of concentrated data into one user interface. Let me contract this to try to visualize almost everything from here. This hunting user interface, there's like with workbooks, the analytic rules and so on, there is a lot of built-in hunting queries that are frequently increasing its number, basically. Here, we can, this is like an accessing to the hunting community, for example, and these available queries are built in and created automatically, aligned for the multiple metric framework tactics on it, on a cyber kill chain. That the cyber kill chain is supporting a multi-tactic stages on it. That goes for example, if we hover over these different icons on it, from the recognizance, let me return to the 100%. Recognizes a stage, resource development, initial access tactic, execution, persistence, privilege escalation, defensive action, credential access, discovery, lateral movement, and many others, up to another 4 for impacting, impaired processing, inhibit response, and known, for example. So all of these built-in KQL hunting queries are associated with one or more than one tactic for this option. And I can use this tactic view for filtering the queries that I would like to display that are associated with this, for example, collection. I would like to see on the top the collection tactic queries on. And then I can see, okay, rare domain seen in cloud. I can see that for these built-in template queries, I can see its descriptions. The description says, this hunting query will identify rare domain accounts accessing or attempting to access cloud resources by examining the audit logs on it, the office activity and signing logs. Rare doesn't mean malicious, but it may be something that you will be interested in investigating further. And additionally, it is possible that there may be many domains if you have allowed access by third-party domain accounts. So you can lower your domain limit value as needed. For example, if you only want to see domains that have access attempt count of 2 or less, then you can set your domain limit equals to 2 below. If you need to set it lower only for a given log, then you can use a custom limit in the same way and uncomment that line in the script. You can find out how the script is created. You can click to view the query results, and you will expect to see the results in seconds, for example, if you have some data from there. You can take a closer inspection to the query that usually with these hunting queries, you will find out some more complex options because you are going to union, merge, and run operations against the correlation of multiple tables to find out suspicious conditions, for example, on it. And when there is, this query will be associated with multiple tactics from the me-tree attack for trying to find some vulnerabilities in our systems, for example. We can create our custom hunting query, and we can take the querying from the templates. We can also run at the same time all of these queries from the list, or we can use a custom selection from the hunting list, for example. I can just configure the filter by removing the tactic collection option, and I can click on, I would like to run all of the queries at the same time. Summary of users, PowerShell download, new process observation, masquerading files, uncommon process, anomalous signing in locations, and so on. And then I can click run my selected queries on. I will expect to see if it is something suspicious to investigate these results options, results column, results delta columns on it. And when I find something on this one, then I can pay attention for this one, and I can start adding bookmark. The bookmark will be like a, remember that you just find something suspicious here and you would like to investigate in the future, or you would like to pay attention for this one. Or I can just focus on a single query on it, or I can create my custom query and add it to my built-in template list that I can associate a name, a description, the custom query by copying and pasting it or by writing it here, but it will be a good idea for testing it first from the query editor, and then when I finish with that, copy and paste it there, and to save it as a new hunting query from my private repository. Entity mapping and the techniques that you consider that is associated, and you can click on save and create it, and you will see it as your custom along with your active KQL hunting queries here into this list. All right, guys, we reached the end of today's event, and we just completed the entire content to cover for this session number 3 and day 3, and for the objective of the Sentinel server, how they work and how we can use it and perform operations against incidents, alerts, creation, collection, integration with the workspace, hunting, KQL editing, accessing to the log and